problem set number 4, question number 12, the last one of the problem set. This is one of those questions where we take the kind of stuff we've been doing and then rearrange it so you have to do something new and fun and exciting with it. And in this particular case, you are given an observation and you are asked to calculate what the mean is from it. So graphically, we would draw our distribution here, and the question specifies that this is a normal distribution, that even though I have a 50 years in there, that is not to be treated as a sample size, that is just to indicate that we are comparing it to a long-term mean. In this particular question, we are given a probability, 30% or 0.3, and we are given an observation, a earthquake magnitude of a single event of 3. So given that we're talking about an observation of 3, this distribution needs to be considered a distribution of observations. And that means distances are in units of standard deviations. So important stuff to keep in mind. As always, we'll draw our curve and we'll drop our mean down here. Normally, we're given this, but in this question, this is actually what we're trying to solve for. We do not have a mean. All we have is our observation. So somewhere in this curve, we would be able to draw a line, and that represents a magnitude, an earthquake magnitude of 3.0. Where should we draw that curve? Well, that's kind of the next step that we need to consider. And our key to that is this 30% probability of observing a 3. When I say a 3, it's actually greater than or equal to 3, and that's specified in the question. An earthquake magnitude of 3 or greater. So there's a 30% chance of observing a magnitude earthquake 3 or greater. So there's no particular upper limit given in the question. That means the earthquake magnitude could be way up here, and it's going to drop it down until it reaches an observation of 3. And that area has to equal 30%. So let's just draw it in there, and then we'll repeat that and see if it keeps making sense. So if we drew our line here, and we put a 3.0, this is our observation, we're saying that there's a 30% chance of seeing an earthquake magnitude 3 or greater. So that seems to make sense. This whole half of the curve has to equal 50%. So it also makes sense that our observation is on this side of the curve. This whole thing has to equal 50%, but we're only considering 30%. Then there still has to be some space in between the mean, the long-term mean that we still don't know yet, and our observation. But what we've done is just a quick little check to make sure that, yes, it makes sense to draw our line for our observation on the right-hand side of the curve, and that this should be a kind of one-tailed thing. It's not really a one-tailed hypothesis test, but we're only considering the right tail. So that all seems to check out. That's good. When doing things with probabilities, we can't really use original data yet, or data units. The magnitude or earthquake magnitude of 3 doesn't really help us. We need that 3 in standard deviation units. And so we will need to convert that. We convert that using this Excel function over here. It's the same kind of one that we've seen previously. In fact, it is the exact same one that we used in question 11. We're talking about a normal distribution, so we'll start with the norm. We don't even know what the population mean is, so we have to use the .s version, saying, well, this is just going to be a generic normal curve, and using the properties of the normal distribution, what is the distance away from the mean that results in a probability of 30%? That's the .inv. So given a distance, given a probability, tell us a distance. And yes, again, means we can kind of ignore what the means are in the standard deviations. One trick and one key to this is realizing that even though we were given a 30%, this function works from negative infinity going to the right. So we know 30%, but that's not the part that we need, at least for the function. To solve the question, this is what we need, but that's not what Excel needs. Excel needs the probability or the area Same thing, from negative infinity up to our value. So if this whole curve is 100% or 1, and we don't care about, or Excel doesn't care about the 0.3, it needs the remaining 0.7. So that's what we give it. So we'll ultimately find out how far this is from the mean in standard deviation units using norm.s.inv and giving it 0.7, the area from negative infinity up to 3.0. And Excel will tell us that our z-score is equal to 0.52. So our observation is 0.52 standard deviations to the right. That's a positive 0.52. So that's good, but it's not really the whole thing. We want mean. We want x bar in this case. So if we look at our z-score formula, because that has an x bar in it, we can see that, well, we can use this formula and solve for everything we need. We needed a z-score. Well, we just calculated that. It is the distance from the mean that we don't know yet. We have an observation x that was given to us. It's 3.0. This is what we're trying to solve for. We don't know that. And a standard deviation is given to us in the equation. In the question. It was 2, so we know what that is also. So now we can just do, again, a little simple algebra and do some rearrangement and solve for x bar. And if we do that, we get a value of 1.95. And that is our answer. A long-term mean of 1.95 gives us a 30% probability of seeing an observation, an observed earthquake magnitude of 3.0. And just in case, it's not a bad idea to double check that answer and make sure we did it right. And if I click off my pen and just see what we did here, I just used the exact same formula that we used for question 11, solving for a probability. So now we have a sample observation, we have a sample mean, this is what we just calculated. We have a standard deviation and all that, so we should be able to just calculate the probability of this area under the curve, given, again, our sample observation, our sample mean, and a sample standard deviation. So we plug that into the norm.dist function. There's our observation. That B35 is the long-term probability, the x bar that we calculated previously, standard deviation of 2. The Excel function requires the true flag, which means it'll give us the probability from the left up to our value. And again, that's not what we want. We want the complement of that. We want the right-hand side. So we have to take the complement, 1 minus what it gave us, and we get 0.3. Well, great, because the question told us this should be 0.3, and it is 0.3, so that means we calculated x bar correctly.